Hello everyone. Let me start with a curious thought. Why is it that your body doesn't want to wake up on a Monday morning? Physics says it's not just you being lazy, it's the universe's rule called inertia. Inertia is the stubborn property of matter. If something is resting, it doesn't want to move. If it's moving, it doesn't want to stop or change direction. A football on the ground waits until you kick it, and once rolling, it wants to keep rolling unless friction, a wall, or a goalkeeper interferes. So here's the key. Inertia is not a force, but a natural tendency of objects to oppose change. In short, velocity stays unchanged unless an external force interferes. Now let's travel into daily life. You're sitting in a car, relaxed, and suddenly the driver slams the brakes. Your body lurches forward, right? That's inertia of motion. Your body wanted to keep moving even though the car stopped. Stand in a bus as it suddenly starts, your feet move with the bus, but the rest of your body resists, and whoops, you fall backward. Shake a tree, and leaves fall because the branch moves but the leaves resist. Beat a dusty carpet, and the dust particles fly out because they wanted to stay at rest. All these everyday events scream the same truth. When the total force is zero, motion stays constant until an external push or pull disturbs it. Now, here's a big question. Do all objects have the same inertia? Of course not. That's where mass comes into play. Mass is the measure of inertia. The heavier the object, the greater its stubbornness to change. Kick a football and it happily flies. Try the same with a stone of the same size and ouch, your foot hurts because the stone's mass makes it resist the change. A train resists acceleration far more than a bicycle under the same push. That's why inertia is directly proportional to mass. More mass means more resistance to changing motion. Let's make this fun with experiments. Place a coin on a stiff card over a glass. Flick the card sharply. The card flies away, but the coin drops straight into the tumbler. Why? The coin resisted the sudden horizontal motion and preferred to stay at rest. Another classic, stack carom coins and strike the bottom one. Only the bottom coin slides out while the rest fall vertically. Why? Their inertia kept them at rest, unaffected by the sudden strike. Both activities show that inertia resists sudden changes. Only the part directly acted upon moves instantly, the rest stay put until a force reaches them. Let's compare and rank inertia. Which has more inertia, a rubber ball or a stone of the same size? The stone. A bicycle or a train? The train, obviously. A 1 rupee coin or a 5 rupee coin? The 5 rupee coin. It's simple, more mass means more inertia. That's why a boulder stays unbothered by a gentle push, but a light ball rolls away with the same effort. Heavier objects resist change, lighter ones respond quickly. Okay, let's put numbers to this idea. Suppose you apply a force of 10 newtons, that is 10 units of force, on two blocks. Block A has mass 2 kilograms. Block B has mass 10 kilograms. Using Newton's second law, acceleration equals force divided by mass. For block A, acceleration equals 10 divided by 2, which is 5 meters per second squared. For block B, acceleration equals 10 divided by 10, which is 1 meter per second squared. So, under the same push, the lighter block zooms ahead while the heavier one moves sluggishly. This is inertia in action. Greater mass means greater resistance to acceleration. Let's bring it all together. Inertia is the property that resists change in motion. Mass measures this inertia. The more massive the body, the harder it is to accelerate or stop. We saw it everywhere, cars braking, buses starting, shaken trees, flying dust, stubborn stones, and easy rolling footballs. Experiments with coins and cards prove the same thing in classrooms. And the golden takeaway? Acceleration equals force divided by mass. When mass increases, acceleration decreases. Same push, different results. So the next time you're asked to push a sofa and wonder why it feels like gym training, remember, it's not just the sofa being stubborn, it's physics. Inertia and mass are reminding you that heavier objects resist motion more. I hope you now feel confident enough to explain inertia and mass, whether in class, at home, or even while doing the carom coin trick at a family get-together. See you in the next session, where Newton's second law, the famous force equals mass times acceleration, takes center stage.